Right. Hello, everyone. Thank you for joining today's office hours webinar. I'm Mike Pacheco, Senior Product Marketing Manager with Vast. I'm thrilled to be your host for today's webinar. I really appreciate all of you joining. Thank you for your attendance, and we really look forward to hearing from you. We truly appreciate you being here and for your participation. Um, Before we kick things off with intros, I just wanted to give a high-level overview of what we're going to be talking about today. So we're going to be talking about one of our latest innovations and talking about how that innovation can help you streamline your, and simplify your AI pipelines in Google Cloud. So for those of you who may have been following us at Google Cloud Next, we made an announcement. Basically, it's an integration between our Vast Data Platform and Google Cloud. And I can tell you that here at Vast, we definitely view this as a monumental stride in our continuous quest to, simplify AI-powered discovery. In a nutshell, this integration allows you to kind of bridge your on-prem and cloud locations to help you streamline leveraging the elasticity of the cloud and simplify your utilization of cloud services related to compute or analytics or data management. So just picture for a moment your being able to burst your data from on-prem to the cloud, without having to worry about hefty data movements or complicated setups. So that's what our global namespace empowers you to do. Easily leverage your on-prem data in the cloud. So without further ado, Josh and Andy are going to double click on what I just talked about. Josh Wenzel, he's our solutions architect. He's going to kick things off, and he's going to be providing a technical overview of what the solution is, what's actually deployed in Google Cloud, and how it works. He's going to be handing the baton off to our esteemed Andy Pernsteiner. He's our Field Chief Technology Officer, and he's going to grace us showing this in action with a demo. So we obviously, I think many of you have been to these office hours sessions before. We like to keep them technical. We also like to keep them very interactive. So we fully hope and expect and encourage you to ask questions along the way. So if you look in the Q&A section of Zoom webinars, get your questions in there, get your comments in there. All of us are going to be watching, and we'll do our best to answer your questions as quickly as possible. We also have two very simple poll questions. You're going to see them pop up on your screen. When you see them pop up, if you would kindly take a brief moment to answer them, we would greatly appreciate your input to those as well. So let's kick it off with our first poll question. And that question is, what are your biggest issues with getting your data into Google Cloud? So there are four options here: data gravity, limited ways to move data, cost, or time. So I don't think we need to explain what these things mean, but data gravity in a nutshell is, just picture you have data, and that data is continually amassing. And as that data continues to grow, the dependencies on it continues to grow. It's different systems, different applications, different users, different services that are dependent on it. So it becomes harder to manage and protect and secure and mobilize and comply with. That's data gravity. Next is limited ways to move data. Well, because it's in so many different locations and secured different ways and used by different users with different applications, it's hard to move. We can't really figure out how to do that. Maybe we don't have the correct tools to help us do that. The next one is self-explanatory. It's about cost. It could be financial cost related to concerns or research you've done on storing and retrieving data back and forth from the cloud, or it could be operational costs. Maybe you have resource constraints and you're just not quite equipped to figure out how to do it. And lastly is time. Time could be, from a management perspective, from an administration perspective, but it could also be, we could also factor in the length of time that it takes you to move data from point A to point B, C, and D. So those are your options. And I see that several of you have answered. Thank you so much. If you would just take a brief moment to flash the poll results up on the screen. Oops, sorry, folks, technical difficulties on my end. For some reason, I'm not seeing the poll results. It appears to me they're being shared with you all. I just don't see them on my end, so my apologies. But, hopefully, you know, as Josh and Andy go into their respective areas, you'll start to understand how simple this solution is, the use cases that it can uncover for your organization, and hopefully that'll help mitigate some of those preconceived concerns that you may have with, moving data back and forth to the cloud. So without further ado, I'm going to hand it off to Josh. Josh, can you tell us, what are we deploying in Google Cloud?
Yes, I'm Josh Wenzel, Solutions Architect of the Office of CTO team, and I'm going to give a brief high-level overview of what VAST is deploying in the Google Cloud. And while our GCP VAST on Cloud cluster is not yet publicly released, it will be soon. Here's how we are enabling you to deploy VAST clusters into your cloud environment. The important
I think we may have, as is the case sometimes on live webinars, we have technical mishaps. So
yeah, so just I'll take over. Josh is talking for a moment while his connection gets sorted out. He's actually in a data center right now in a side room. We're moving a bunch of lab environments around, as can happen sometimes, and so he's popping in from there. And I can kind of cover what he was talking about to some extent until his audio comes back online. But basically, what we've allowed customers to do is deploy a VAST system in Google Cloud in the sense of being able to deploy within their own VPC. So it's not as if it's a managed service by VAST. We're not hosting it for customers in Google Cloud. We're allowing customers to deploy it. So basically giving an image as well as a series of playbooks and automation to be able to spin these things up. And it's going to be available in the general purpose marketplaces very soon. And once that's available, then customers can then use those either as sole, standalone instances within GCP, or they can also use it in conjunction with a VAST cluster that's on-prem or in another location for the purposes of global namespace. I'm not sure, Josh, if your audio came back. If it is, you can talk. If not, I'll keep talking.
You've summed it up a bit. I don't know if my audio is working yet or not, but that is essentially what I was going to cover.
Great.
all right. Thank you so much, Josh and Andy, for kicking us off with an overview. So we do have our next poll question, which is, do you have a need for cloud-based services for data that originates on-prem? So either this is something that you're already doing, something you've started to explore. Yes, I know all these awesome services exist in the cloud related to analytics and AI and database and compute and data management, etc. Obviously, I'd love to be able to leverage those. The next is no. I've researched it. Absolutely have no use case for this. The third is maybe. The third is, I'm kind of up to speed on this. I know what the capabilities are. I'm not yet doing it today. I'm not sure. I need to learn more about it. So those are the three options. Yes, no, and maybe. And it looks like we're almost 50-50 split here between yes and maybe. So I do have a quick request. So at the end of this session, there's going to be a survey that we'll all see pop up, and you'll also be receiving a link to that survey. There's going to be an open-ended input form as part of one of the questions. So for those of you who answered yes, or for that matter, for those of you who answered no or even maybe, if you would kindly elaborate on the use case that you have related to this. Like, what is the use case? What are you looking to accomplish? What is the cloud service? Like, what are you looking to do? We would really appreciate that. So thank you kindly for your participation in that poll, folks. All right, if we would go on to the next session, and now we can kick it off to you, Andy.
Okay, great. So what I'm going to do is I'm going to walk you guys through a scenario in the lab where we're allowing for two different clusters to talk with each other. And this is the same functionality, regardless of whether you're doing this on-prem or whether you're combining it with cloud. And so effectively, we can allow for two different systems or even more than two different systems to be able to participate in a global namespace in the sense that data which is written in one location can be read and written to in another location without the need to do any kind of quiescing or migration or any kind of movement manually. It gives the ability for users or applications that are in multiple geographically dispersed locations to access data without having to do any extra efforts. So what I'll do is I'll share my screen. One moment, please. Sorry, I gotta get this queued up. Yeah. Sorry, I have too many monitors today, so it takes a moment or two for me to get it going. Okay, you can see my screen, right?
Looks good, Andy.
All right, so what I'm going to move pretty quickly. So I have two clusters. Right now, I'm on the cluster that's in California, and I noticed that I have a system it's connected to, which is in actually in this case New York. So I named them V93 for California, V218 for New York, and then I have a path. In this case, it's the video path or /video, and this is a view. So this is basically how we expose things in our system to allow people to access it, and it's exposed over NFS v3. And then right now we're leveraging the underlying replication engine that we built to be able to do global namespace, but there's a few attributes that are different. So if I go ahead and look at this protected path, so I'm taking the /video path on the lower left, and I'm allowing it to be accessed in the other cluster as /video-global. I just wanted to give it a different name. And it's marked as global access, which basically means not that it's being replicated, but rather that it is participating in a global namespace. So if I switch over to the other cluster, the one that's in New York in this case, look at the same protected path config. In this case, it's the /video-global folder, and it is acting as a target. Now, target doesn't mean that it's a read-only target. It's not replication in the same way that you might be used to. What it is that in our global namespace implementation, there is an owning system for every path, and then there are the satellite systems. And the owning system, and I'll also just show you that this is also exposed over NFS. The owning system is able to do what we'll call lockless writes and lockless reads, so it's a little bit faster. So on the left-hand side, we have California. On the right-hand side, we have New York. We're in the same directory structure on each side. Let's do a quick little ls-l. We can see that the file names are all the same. So far, so good. Now, the whole point of this is to show you that we have the same path accessible in two different locations without needing to go and do any actual data movement itself. And so then what we'll do is do a quick ping test just to show you what the latency is between these two sites. So I'll ping one of the IP addresses that's on the California cluster from the New York side. In this case, I see there's about 71 milliseconds or so of latency. And then I'll just ping another one of the addresses to make sure that there's no differences, right? So again, 71 milliseconds. Obviously different sites will have different latencies to each other. And then I'm going to open up an editing software on the California system. So I'll maximize this to make it a little bit more obvious what I'm doing. So this is a video editor. It's an open source video editor. And I'm going to import some video files. Yeah, sorry, go ahead.
I'm sorry to interrupt. I just want to make sure right now what we're seeing is a single slide, but it looks like you're talking about a separate window.
Oh, crap. I'm sorry. I was sharing the wrong thing.
If you would kindly just backtrack about 30 seconds or so.
1 second. Let me do this again. 30 seconds. What was the last thing that you saw?
Actually, the only thing we saw was that slide the whole time.
Oh, I wish. Okay, I should backtrack a whole minute then. We'll start over. I will share the right screen, I think, this time. What do you see now?
Excellent.
Okay. Okay. So here's what I'm going to do. I'm going to go real quick now. So I'm going to show you that we have a cluster. It's the California cluster V93, and it's connected to V218, which is the New York cluster. And the whole point of this is that there's two clusters are talking to each other, and they're peered in a relationship. And this looks the same as you would use for our replication, but it's a little bit different. So If I take a look at one of the views or the exports that I've set up for data on the California cluster, the /video folder is being shared or exported. We're using NFS v3 as the protocol. Then I'll go in and take a look at how we're allowing it to be served as a global namespace path. It is still using the underlying replication engine that we built for standard replication, but there's some nuances. So if I scroll down to the bottom, and then we take a look at the way that it's set up. On the left-hand side, you see that it's set up as the source for /video. On the right-hand side, the target, it's kind of small, is the /video-global directory. And you notice it's set up for what's called global access, not for replication. Then we'll go over to the other cluster, the New York cluster. And in this case, it's also set up. And if you look here, it is the target effectively. And as I mentioned a minute ago, the target doesn't mean that it's a read-only target. It means that it's just participating as a satellite or edge cluster in this context. So every directory on a vast cluster, I'll show you, it's got the same sort of exposed view over here, but we named it differently just to make it more obvious. But every system can own or be a satellite for any given path. And on the right-hand side, we're just going to do a quick little ls-l in the same directory that's on the left. So the right-hand side is New York, left-hand side is California. Same data, same files, everything. But as I mentioned before, just because you are a satellite system doesn't mean that you can't read and write to the data set. You can read and write. It just means that the latency might be a little bit higher because there's some amount of metadata exchange that needs to happen between the two clusters in order to make sure that everything is consistent. So I'll do a quick ping test. I think we were getting about 70 milliseconds a second ago. Hopefully it's about the same. Yeah, about 71 milliseconds. And so, and I'll ping, there's a couple different virtual IP addresses. I'll ping another one of them just to make sure that they're the same as each other. But there's 70 milliseconds latency. And, normally if you had a workflow, you would have to copy files back and forth. You have to tell people to wait. So I'm going to open up the OpenShot editor in California. And in California, we have all the assets that are loaded on a cluster there. This is just a client machine running Linux. OpenShot's an open source editing package. I'm going to open it up and import some files, some MP4 files that are like videos that one of my colleagues recorded when he was on a trip. We'll just drag some into the timeline. Let's just grab a few random ones. And, so basically all I'm going to do is show you, look, I can make some edits in one system and I can play them back in another, right? And so we'll just do a quick little playback. I know it's a little bit small, but you get the idea. There's some video. It's playing back. It's all local at this point. There's no global namespace thing happening yet. This isn't anything special so far. We're working again on the California system. And then I'll save a project file. Now, OpenShot, just like every other video editing software, it's not like you export the entire gigantic thing. You have a little project file. So this is just a project file. It probably looks like an XML file underneath the covers. And it contains all of the sort of relevant metadata bits for the project, the timeline, everything else. And now I'm going to get rid of the California window and we're going to go maximize the New York side. And then I'm going to go and do a directory listing in the parent to show you that we now have the animals file. Now, you notice that the latency when I did that directory listing was a little bit longer than normal. That's because when it does that initial directory listing after something has changed, there's some metadata that has to get shipped. The client doesn't know anything, but it might take a little bit longer the initial time. And then after that, it's going to be fast. So we're going to go and open up that project file in OpenShot, again, in the New York system. And once we do that, we notice it spins for a little while because it's loading in the project file, but it's also loading in some of the video assets or some portions of them. It only ships the bytes that it needs for global namespace, but once they're there, then they're cached. And then if I wait a moment or two, I can hit the play button. And then if I hit the play button, we can watch and we see that there's some video there and it's playing back. And this is effectively playing locally from the user standpoint, but we might be shifting some bytes across the wire to make sure that we stay ahead of what the client is doing. There's some prefetch algorithms that are built into it. Obviously, it's a cache in a lot of ways. But in this way, I didn't have to do anything. I had to call anyone and have them copy a file over. Someone just saved a file into a directory, and then it's immediately accessible in the same basic folder structure in another location mounted to a different client. Let me make a couple quick little edits. I'm going to cut up, maybe chop some stuff out, apply some filters, just so that you can see that I can make some changes. I can do read and write on the other side. So it's not as if it's a read-only copy. Again, I can do reads and writes. Let me add a little filter to zoom in. And then I'll add another filter to a different segment. We're just going to do something basic. I'm not a video editor. I just know how to like press buttons. So I'll go ahead and press a couple more buttons. And then we'll play it back and make sure that we like the way it looks. Get to the beginning, hit play. And so now I have this little wavy effect, and then it'll transition to the next effect, I think, which is that little zoom in thing. Okay, yeah, so now there's a squirrel eating nuts. Okay, great. So I can pause it. I'll save the project file, which is, again, that little OSP file. And then let me switch back over to the California client or the California system. And if we go there, the thing is OpenShot doesn't know that the file changed, the project file, so we're gonna have to open it again. So basically reload the project. This is pretty normal. So I'll open it up again. Once I open it, I notice that the timeline has changed. And if I hit the play button, well, all of my effects are applied. So basically what I did is I had two different clients in two different geographically dispersed locations with 70 milliseconds of latency. I was able to make edits and load projects and do things in both locations, and the other side was able to see them pretty much immediately. Slight delay in terms of latency when I initially did that, but it wasn't something that was getting in the way of the work, right? And so I think that the key thing here is that you imagine workflows where there might need to be data sharing, both read and write in multiple locations by either different users or applications that are part of an automated pipeline. You can do so without having to move the data first. You can do so without having to make an extra copy of the data. You can do so without having to ask somebody to stage something somewhere. They just work in the directory they're normally working in, and someone in another location can easily access that without having to do anything special. So that's pretty much all the demo that I have for the day. We have some other ones that we've done specifically related to GPU training, especially if you're using spot instancing in GCP. Oftentimes the spot instances will get preemptively killed by Google for, sort of capacity reasons. When they do that, oftentimes they'll send an API call to you, which will allow you to know that the instance is going to be terminated. And so then you can have another part of your pipeline go spin up another GPU server in another region. And if you have a global namespace path based on VAST that has access to the data as well as the checkpoints for the GPU training jobs, then you can automate the ability to transition training from one location to another without having to move any data or make any copies. So it's actually very useful for things that are maybe less obvious at first. Like you can do all kinds of things once you have the ability to be able to read and write data without having to worry about where it is. That's all I got for now.
Thank you very much, Andy. So as I mentioned earlier, we like to keep these sessions as interactive as possible. And it looks like we do have a couple of questions in the Q&A area. So we will take a couple of those. The first of which is, I'm interested in this global namespace extension. Are there limitations we should be aware of? Also, interested to hear more about potential data security implications for this with multi-cloud environments. So I guess paraphrasing that, I'm interested in this global namespace. Are there limitations we should be aware of? And looks like the second part of the question is, are there potential security implications with multi-cloud environments? So Andy and or Josh, either of you have thoughts on that one?
I'm sorry, I lost track of the question.
So I guess the question is, I'm interested in global namespace. Are there any security implications to be aware of?
Sure. Well, so the first thing is that the way that we've implemented it so far, there's a couple different layers of security that people think about. One is they think about network transport security in terms of moving data between two different locations, potentially over a wide area network or the internet. Now, obviously, we always recommend that people use a virtual private network or some kind of secure link to do transit across the wire, but we also allow for TLS-based encrypted data in transit. So basically, the way that even the way that regular VAST replication works is we can replicate using TLS, and you can supply your own signed certificate so that we're not relying on self-signed certs. So that's one thing. So all data that flows between source and destination, regardless of whether it's replicated data or global namespace data, is encrypted over the wire. The other thing that people consider is, okay, well, who has access in which location to the data itself? Because it may not be the same set of users. It might even be a completely separate entity, right? You might be sharing data with an outside entity or one that's a subsidiary, and they may have different authorization requirements. And there is a model whereby the directory or the path that you are allowing to be exposed, let's say in one of the satellite locations, can have a different policy in terms of who accesses it. Now, there are some file system level permissions or ACLs that are going to be consistent between the two locations, but we have a couple different options for allowing access to be less file system based and more policy based. So, it really depends on what people want to do, but generally speaking, if you want to do something in terms of sharing to one group of users in one location, but then to a different group of users in another, we do have a facility for doing that due to the way that we've implemented our authorization schemes.
Excellent. Thank you so much, Andy. Looks like we have another couple of questions that just filtered in. The next question is, for a big migration of data from an on-prem storage appliance to a cloud, does VAST recommend using a certain type of network connection? For example, over the internet or over a private transport link? Are you compatible with Google Connect or Packet Fabric, for example? Similarly, for between clouds, for migration or steady state transfer between clouds?
Yeah, so we are a bit agnostic in the sense of the network fabric that we use. In terms of compatibility, we need a TCP/IP network that's routable in some way to the destination, right? So basically on the source cluster or destination, however you want to look at it, you would end up having some set of virtual IP addresses that participate in the movement of data. So within VAST, we have a couple different ways that we expose IP addressing schemes. One is for user traffic in terms of people accessing data over S3 or NFS or SMB. But then we also have dedicated network IP addresses and potentially subnets and VLANs just for either replication traffic or for global namespace traffic. And the reason we separate them is because oftentimes customers will have different routing, different routers, different gateways, potentially different physical fabrics based on what the traffic is being used for. That's one thing. The other consideration is that, yes, we just need TCP/IP. In terms of what we would recommend, obviously the highest bandwidth is possible. We are less concerned about latency in this context with some level of caveat, but because basically, if you imagine, in a lot of cases, when people are transferring large files over a wide area network, there's a lot of sensitivity around latency because oftentimes file transfers are single threaded in nature. And as you probably know, if you have a TCP link that is high in latency, then the single threaded performance is pretty abysmal, right? Over a 70 millisecond link doing like an SCP or an rsync of a single large file is going to take a long time. But if you increase the number of threads that are participating in performing that transfer of data, then you will get to a place where you can have enough concurrency to fill the pipe even when there's high latency. So underneath the covers, when we are basically chunking up data to send either for replication or for global namespace traffic, we don't do so on a per file basis. We're splitting it at a much smaller granularity level, and then we're packaging it into, we call them crates internally, but then we end up shipping those using multiple threads between the source and destination. And so in that way, you can get a lot better bandwidth, even if the latency is high. In terms of any, sort of vendor specific implementations or cloud specific implementations, we're pretty agnostic. We're not sitting so far down on the stack where we have control over the network layer. We're just putting packets in the wire, and we need to make sure they're routed properly. I can actually read through these questions. You don't need to read them out loud. I'll read them out loud really quick. Another person asked if this has been used in the DOCD or IC community with Fed certs. I'd have to defer to one of my colleagues who focuses on the federal community. I'm actually not allowed to work with them because of the way our entities are set up. But we do have some level of validation with them. It's not necessarily for this particular use case, though, of sharing data between public and private or between different cloud providers. So we'd have to dig into that one in more detail. And then someone else asked a question in the demo where the satellite updated a file. At what point does the source side know if it changed? Seemed like it was at open time. So there's a couple different aspects to think about here. I know that in the UI, there is this concept of source and destination. And we've kind of toyed with what words to use to make it more clear. Originally, I'd used owner and borrower, but let me explain the flow a little bit in both scenarios. So let's imagine that you have a directory in California where you're primarily reading and writing in California. Maybe that's where the data is ingested. Maybe that's in this case where the video editors are getting their initial footage from. And then you have someone in New York who has to do edits and cuts and apply filters or whatever. So you have to choose on a per directory basis which cluster is going to be the quote unquote owner for that directory. Now, what does an owner mean? So an owner basically means that whenever it attempts to do a write, it doesn't need to do any kind of lock or lease mechanism to go and ask the other side for permission. It can just read and write locally directly to the system. Now, in the case of the other system, so in the case of New York, it is a borrower site or a satellite site. And so when it does a read, obviously it checks to see if the metadata it has is current. And so there is a little bit of an exchange of metadata to identify if anything has changed since the last time that it checked in. There's a little token-based system that we use. And then if necessary, it will read the bytes that it needs to and read the metadata blocks that it needs to in order to satisfy the user's request. So the user types in ls-l, and then behind the scenes, the system in New York is checking to see if anything has changed since the last time that it did any fetching of metadata from the San Jose or from the California system. And if so, then it goes and fetches what it needs to be able to supply the request back up to the user. Now, in New York, if the user wants to write, if they want to save a project file, or if they want to create a file or something along those lines, when they do that, because it's a satellite site or a borrower site, there's a higher latency penalty for writing, because what happens is the write request comes in from the client, it goes to the NFS server within our platform, and then the NFS server goes and checks in with what we call the element store layer, which is our file system layer. And it checks to see that, oh, I'm a borrower location or I'm a satellite location. What that means is that first, the borrower location has to go and negotiate a lease with the owning location to make sure there aren't existing rights going to that same file, same offset, same block, right? And assuming that a lease is granted by the California system, then the New York system will write. And in this case, in the initial release, we're basically doing a write through where the acknowledgement doesn't go back to the client until the data is persistent in both sites. So if you write to a borrower or a satellite site, you will not get acknowledgement back to the client until it's been persisted to the owning site. At the owning site, you get acknowledgement the moment the owning site has it, but then all the borrowers basically have to check to see if they have the most recent version. That's generally speaking the way that it works. We are going to be adjusting this flow over time to make it a little bit more optimized, even at the borrower sites, but that's how it works today. And then when you ask the question, do you support shared rights? Let me think about the way to answer this one. So let's maybe what you're asking is related to single file multi-writer. So if you have a single file and you have multiple writers concurrently to the same file, it's not as if the lease or the lock is for the entire byte range for the file. So we can actually do finer grain leases, which will allow for multiple writers to the same file, but that does rely on the application being smart enough. So it's not as if we're going to throw back an error to the application if they try to go across a boundary, right? So if, it's similar to like an NLM lock in a lot of ways. You can allow for sort of byte range locking to the same file handle for the first 10 bytes for one client, the second 20 bytes for another client, whatever. It's the same is true here, except in this case, the client doesn't even need to ask for a lock. It says, I want to write to this file handle from this offset to this offset. And then the lease is for that level of granularity for the file handle plus whatever the offset is. And then if the client in New York, again, wants to go and do another write for a different set of offsets, it has to get another lease. On the other side, it doesn't need to get a lease, but if it has offsets open for writing, then the lease won't be granted to the New York side if it asks for the same overlapping byte range, if that makes sense.
Excellent. Thank you very much, Andy, and thank you very much to all of the questions that came in. We really appreciate it. So if we advance to the next slide, we do have a closing slide that I want to share with you all. So you know, we want to make sure that you all have an opportunity to follow up with us. Maybe you have some feedback on the session. Maybe you have questions that are unanswered. Maybe you have a desire to engage with us post-webinar in a more intimate setting, one-on-one, for example. So we have a survey. I think it's 2 very short questions. As I mentioned, there will be an open-ended mechanism for you to, you know, let us know what you think. Maybe tell us about some of your cloud service use cases from the earlier poll question. You can alternately scan the QR code. After this session ends, you're going to see the survey pop up on your screen. And don't worry if you miss it, because post-event, we're also going to be sending a follow-up email with a link to the survey as well. So please be on the lookout for an email from us. So we'd love to hear from you. I just want to thank you sincerely again from all of us. Thank you for joining. I really appreciate how interactive this was, and I really appreciate your questions. I hope to see you all on the next one. Have a great day, folks. Thank you.